Hello and welcome to today's webinar on rural road design. If you don't know me, I'm Erin. I'm one of our resident webinar hosts here at Softrate. I also happen to be the business development manager. So today's webinar is going to take a little twist from our usual webinars where we talk about a singular workflow, sort of front to back in the software. So today we're going to do something a little bit different and we're going to cover a few more bases. So if you're working with different survey data types, and if you have different versions of RoadEng, including RoadEng with Optimal or just regular RoadEng, we're going to be giving you both a workflow. So today we've got a couple sort of core learning objectives, and we're going to get to all of these twofold throughout the webinar. So we're going to start talking about how you can input your different survey data. We'll talk about how you can create horizontal and vertical alignments for your road. We're going to talk about how you can streamline earthwork balancing. We're going to talk about culvert integration and being able to add pipes to your road design. And then we're going to talk about effortlessly creating, and when I say effortlessly, I really do mean effortlessly, with a couple clicks, how to create some detailed output sheets. So today we're doing, as I said, something a little bit different. We are going to be doing rural road design two ways. We're going to be pitting two of our different webinar hosts, Diego, who is our lead for Spanish webinars, against Matt, who's your typical presenter here on the English side. So Diego is going to get to work with LiDAR data, and he's going to get to play with optimization tools. So he's going to have RoadEng with Optimal. Matt, on the other side of things, is going to be handling the more sort of conventional design. He is going to be working with total station survey data, and he has no access to optimization tools. So today's webinar is going to be a little battle between Matt and Diego. So the project that we've given them both is a road realignment. So they're going to take an existing road that is below standard, and their job is to realign that segment of that road, updating it to a 50 km/h design speed. They both need to keep their min-max grades within ±8, and look to obviously do it in a way that produces, a good result, minimizing their earthwork costs. So that's our project. This screenshot obviously coming from Diego's side because that's a bunch of nice LiDAR data on the left. I wanted to just quickly mention, if you are new to the software, first off, what is RoadEng? If you haven't heard about it before, it is a geometric design software really built for rural infrastructure applications, and this realignment project is a perfectly suited one for it. The software itself is modular. So both of our presenters today are going to start in the terrain module. This is where they are going to import their survey data and create a surface. Then they're going to both pivot into the location module. And the location module is really our specialized sort of mini program where you can work with alignments and linear infrastructure design in a really easy to use and friendly environment. There is an add-on. Diego's got access to this today. That's Softrate Optimal that allows him in the terrain module to leverage another tool called Path Explorer. This is going to help him figure out the best way to get from the start of his realignment section to where he wants that realignment to end. And then within the location module, he has access to earthwork optimization tools, specifically using the vertical optimization tool, which is going to minimize the cuts and fills for his vertical profile, reducing cost and improving the efficiency of his design process. So I'm going to pass it to Diego first. A quick intro to his workflow. As I mentioned, he's starting in terrain. He's going to import his data. His project's data is LiDAR. However, the workflow he's going to show you is kind of synonymous if you're working with, say, drone data or DEM data. So he's really kind of representative of that high resolution point cloud. He's going to take that data, he's going to create a 3D model, which we call a TIN model, standing for triangular irregular network. And from there, an opportunity to add some extra spatial data if he's got it. He's going to do some path exploration, and then he'll save that file as his TERX model. And that TERX model, and this is going to be the case for Matt as well, is really the foundation for that location project where we talk about roads specifically. So he creates a new file, references his topo. These steps, a couple of them are going to be very similar between the two of them, but you set up your cross-section template. He's going to leverage the optimization tools to convert his path into an alignment with proper curves, automatically generate his profile. He has an opportunity to review and fine-tune, add some culverts, and then look at creating output. In this case, we're going to look at output sheets with multiplot. So that is my very quick introduction. I'm excited, new format. Let's get into it. Diego, the presentation is coming your way.
Thank you so much, Erin, for that introduction. So here we are. We are in terrain model, as Erin said. So we will start by inserting our topo data. In this case, our survey is LiDAR data. We have some cloud points with LAS format. And here in this tab, we can see our projection that it's already settled. Let's hit OK to import our point clouds. We can see those points over there. And if I click outside, we can stop drawing them. So I'm going to use this frame just to import our live maps image and to use it as a context and a background for our project. Considering we don't want to render all the time our points, it's really good to have some idea about what's happening with our project in that area. So in this case, I'm using Google, but we can use another source again, like MapTiler or Bing, for instance. So let's in this, let's save this file. In Options tab, we will set the image quality to high. Basically, most of the time, that's the only thing we will need to modify. All the other parameters should be fine. Perfect, just like that. So now I'm going to go to terrain modeling because we need our thin surface for all the work we need to do today. And let's set the defaults. I don't want to create any labeling, so let's create only the thin model and the contours as well. Perfect, there we are. I'm going to tile vertically so we can have a look at the 3D and the plan window at the same time. And let's use our hydrology tools for creating our streams and ponds. This will give some context about what's going on hydrology about this project. So let's set our minimum point area to say 100 and stream drainage area to 10,000. We can change or modify these parameters accordingly to our project needs and ensuring that it will match the topo and that it makes sense. So in this case, we can have a look. We have two major streams over here that we will cross because our A to B feature will go through this zone. So let's insert it, insert file, the same procedure as all the spatial data that we used to insert in terrain. And there we are. This is our feature and our A to B feature. I would like to drive it. It's not necessary, but I always tend to hit model and turn elevations off so we can drive the feature on the thin surface. And let's modify the type to thick, medium, and another color, for example, just to visualize this easier. There we are. And selecting again, I'm going to Optimization tab for our path exploration. As Erin said, we have some restrictions for our project. Our minimum horizontal curve radius will be 100. And we have a minimum grade of 8%, -8 to 8%. And let's set our resolution, horizontal resolution to 10 meters. And yeah, just like that. Let's set, we can have a look at the project in 3D window. So we need to ensure that our realignment starts with the same of the orientation and finishes with the same orientation that we had in the original road. So let's choose and modify. Let's modify these parameters to match what we would like to. So for the starting points, we want to go this way. And for the end point, we need to enter to the alignment again with this orientation. Perfect, just like that. Let's hit OK, and let's set our construction zones. So we already created our hydrology with hydrology tools, and let's set these streams as a polyline. Let's create some crossing costs. In advanced parameters, we can use our predefined layers, streams. Let's select them so we can have a look that have been selected over here. Perfect. And let's say that this will cost $3,000 crossing cost for each one of these streams. Let's press OK to apply the change. And there we are. Let's run our Path Explorer. Perfect. It's not instantaneously, but it's quite fast considering what it's doing. We have this unlikely to improve further, so we can hit cancel to accept the solutions. It has explored most of the solutions that can be found, so it's safe to hit cancel. By right-clicking, I'm going to select by name, and let's select this feature that will be the cheapest one, 96K, and I'm going to unselect the A to B. We don't need it anymore. Let's hit OK, and I'm going to save this terrain file. So this will be our topo for the design, or yeah, let's say webinar. A name that we can remember. Let's hit save. So at this point, we just found a possible polyline that will match our needs. And now we will go to location. We jump to location to use that file that we just created in terrain and to design our road. Let's browse to find and select the topo webinar, open. And as I already selected my XPath underscore 96K feature, it's already selected here. Let's say next. The initial cross section is the default, so let's do it like that. Perfect, there we are. So if we have a look at the plan on plan window, we can see that we have too many or several consecutive points. That's why that's because it's a polyline at this moment. So we need to convert it in and create our alignment from there. And I'm going to maximize our section so we can have a look that we already settled our cross section. It's the rural one that comes with our defaults. I didn't apply any change, so let's hit cancel. And let's go to run our polyline to alignment. Our minimum radius should be 100. So let's set like that. Maximum offset distance. Yeah, we're fine with this value. It should take a couple seconds. It's not that bad. And let's say, let's check it out, our results. So let's go to the next IP so we can have a look at the design speed of 50 kilometers per hour. And our radius will be 100 as we expected. Perfect. So this makes sense. And now we lost our profile because when we run our polyline to alignment, the profile is being removed. So let's recover. Let's go to vertical optimization. And what I am asking to the software is we will find a new profile, but at the same time that we find it with some restrictions that we have as the grade, the curvature, and among others, we are optimizing the earthworks for cuts and fills. So we have a balanced alignment while we find the profile. So we will go with the same sections sample with all the points and the minimum and maximum offset for the vertical control. In standard tabs, in standard tab, we can have a look that our grade has been settled to -8 to maximum 8%. That is the same that we were working on Path Explorer AI. And our curvature minimum K for sag and crest are 12 and 11 respectively. And we need to set some control points at the start and at the end of the alignment because we want to, it's a realignment project. So let's add a start of the alignment and our control point at the end of the alignment. And yeah, basically that's it. Let's hit process. Perfect. What our software is doing at this point is calculating and processing 3,876 cross sections while looking for the best vertical profile to optimize and minimize these earthworks movements. So when it's done, we will have a look at the data table to figure out how does it looks like. Perfect. We have this log for feasibility and optimization dialog. We can see some constraints that it found, and perfect. Let's hit OK to accept this. In profile, we can see a balanced alignment, a balanced mass hull, and our curves have been applied with the grades that we expected. There's no anything above 8%, so I really like this solution. And in our data table, we can see our cuts and fills that basically are 6,000 for cuts and fills, 6,162.92 for cuts and 6,139 cubic meters for fills. That's good. Basically, we are balanced internally. And now, last but not least, let's set our culverts. I'm going to open our 3D window so we can activate or display our features from top of surface to visualize the hydrology that we already generated in terrain. So we have a major culvert over here that we will need to create and another in this area. So let's minimize it again. And in plan window, let's see how it looks. So at station, I'm hurrying to know the station, 416.7. Let's create a new culvert. And the other one should be, let's modify this skew. So 70. Just like that, perfect. And the other one should be on at station 299.2. There we are. Cool. And last but not least, we should explore our design. So when we are done with our horizontal and vertical curves, and we are happy with our alignment, we can jump to location in multiple button. We will have this active window and multiple. So let's open a book layout that we already done. That's this one. Oh, I'm going to switch first of all the page size, so it will create the correct one for this generic size that is this size basically. And there we are. So these are our cross sections. If we want to display our culverts, we will need to go to layout and activate the point types for culvert insertion points. Click OK twice for applying changes. And let's have a look at the cross section. So perfect. Here we have our culvert at this point at station 299. And just like that, we have several options for exporting. We can export to DWG, to line XML, depending to our project needs. We have several options for exporting our design. Yeah, that's our optimized workflow.
Awesome. Thank you, Diego. So if you joined us after I did the sort of initial kickoff, today's plan is, for those new folks, we're going to show you road design two ways. So that was Diego. And as you can tell from his picture taken just before the webinar, he's looking very confident in his workflow that he gets to present. So that was a LiDAR, representative of the high resolution point cloud data sets in combination with being able to use the Earthwork optimization tools. So next up, we're going to be passing it over to Matt. He's going to be working with total station data and doing a manual design. So he's going to show you how, if you wanted to click in your alignments, how you can do that sort of manual alignment editing. We're going to be going through that process. So a quick look at his workflow, again, quite similar, the conventional workflow in RoadEng. He's going to import his data. One of the big notes with sort of conventional data, whether that is RTK, whether that's total station, is the addition of break lines. You can add break lines in automatically at the time of import through something called an IOP, and Matt will talk a little bit about that. But break lines add a lot of importance to a model, ensuring that it is correct visually. So we'll talk a little bit about that. He's then going to turn that into that TIN model, the triangular irregular network, the foundation for our original ground surface modeling needed for the next module. He can add some additional spatial data, and then he's going to, very much like Diego did, save his file as a .terx. So that's our native file format coming out of terrain. We'll reference that, start the new location file in the second module. Matt, like Diego, will set the cross-section template. In this case, I think we're just rolling with our default rural road template, but you have an ability to go in and work with a wide variety of templates and template customization, and we're happy to share some webinar links if anyone's interested. From there, Matt's going to create some alignments. He is going to click them in and manually add his curves. Then he's going to manually balance his mass haul. Lucky for us, Matt's a pretty great designer, so hopefully that doesn't take him too long to do that live on the call. From there, he could add culverts, and he could also do some output sheets. Depending on our timing and how long the rest of that workflow takes him, we may skip those because Diego just shared that part with you, so it'd be pretty similar. So with that, Matt, are you ready for conventional workflow in RoadEng?
So, tough act to follow. And of course, Diego did a lot of the heavy lifting for explanation. So I'm going to just more focus on the things that are different between the two workflows and covering everything twice. First big difference here is the survey data that I'm using. So instead of an LAZ or DEM or LAS file, I have the raw survey data. I've got my point codes, I've got some coordinates, and I've got my point number. So just like Diego, I'm going to start out in terrain. And we'll let this get fired up here. And we're going to click Insert File, and we are going to bring in that topo CSV. Now, with this, if I just had the default settings, I'd have these top three options, but I wouldn't have this bottom one. And with this, so if you are doing conventional survey data and you're following some kind of standard specs for what gets exported, you can build what's called an IOP file. And this really streamlines the workflow. So in this IOP file that I've previously saved as a default, so I don't have to do it every time, I've told the software that my elevation coordinate is going to be in the fourth column, point code the fifth, Y coordinate the second. It's comma separated data. The really time-saving stuff, though, is in the code tab. So with this, if our surveyor surveyed some CL points, well, those CL points are going to be connected as a break line with a red dashed line and triangle appearing at the survey points. Whereas if they surveyed, say, a line that's called BL, well, it's still called out as a break line. Different symbology though. And then, what's my fence is not a break line. So yeah, we can just really streamline applying the format. So when we do bring it in, there's no messing around with connect the dots. With this, the survey data is in real world coordinates rather than on a local grid. So I'm going to assign my projection. And what this is going to do is just make it easier to work with other data like our imagery data or yeah, useful for doing the construction staking. So we've brought the data in. We can see we've got a series of points and lines. If we click off to the side, they're not all magenta. We've got the symbology applied that we'd like. And of course, we want to take those points and lines and turn them into a surface. So we'll click terrain modeling. We'll click generate. We can control our maximum side length if we'd like. And in this case, I don't really care about my contours because I've got a lot of information here already visualized. And yeah, I'm just really focused on having a surface. Now, as Diego did, it's always nice to have an ortho image in the background for some extra context. So we'll click import. So home live maps. Here we can select what our map source is. So I'm going to just run with Google. We'll hit save, crank up the resolution here. And let's put that in the folder I'm going to be working in. And ta-da, so we've got an ortho in the background. Here we don't have to worry about running the streams tool since we've already surveyed our streams. I'm going to do one more optional thing, and this one's something that you wouldn't normally do on a by hand design. But just so you guys get an apples to apples comparison, I'm going to bring in a shape file that shows well, the same start and end point that Diego used for his Path Explorer. So we'll hit File, Save As. We're going to save this as topo. And I'm going to switch over to location. So just like when Diego started in location, I'm going to start by clicking New File, and I'm going to reference that topo file that we just created and saved. Now here, rather than starting with a line, I'm going to just start with a single point, and we are going to draw in that alignment where we'd like to put things. So, and again, we took the time to download that image, so I'm just going to throw it in my background here. All right, I'm going to move that start point over to where Diego started. I'll move my endpoint over to where Diego ended. We'll pull this just onto our surface here to start. And we'll click Zoom to extent so we can get a feel for where things are at. So that's our 3D view here starting out. Now, unlike when Diego did it, I'm at a bit of a disadvantage. So I don't have a line to follow. And well, I guess I have an advantage. I've seen where Path Explorer put the line when Diego ran it. But I'm gonna go back in time. So I've been using this example for a while, and I know when I first got this example, what I thought made sense to do here was to just ramp up, get on top of the hill here, pop this bridge, dump it back into fill, and stay high. So I did not, way back when, see that, oh, if I just swing low, because this curve doesn't match our design speed, swing low and come up as Path Explorer did. So we'll pull this out here. Now my various views are going to update in real time. We can see our profile has changed. I'm going to put that there. I'm going to pull this over here. Now I don't really want that going over those mess of streams. So I'll pull this down here. Now this is inevitably a slower process than optimizing it, so I will apologize for boring people to pieces here, but yeah, we're doing it acoustically. We're not using all the tools at our disposal by not optimizing it. But with all that being said, it's still super useful to be able to choose where you put your road and have everything update in real time. So I'm just cycling through. I am going to run with a 100-meter curve here for all of these unless they don't look right. And I'm kind of happy with my plan here to start. So designing by hand, it's not necessarily just a linear workflow where you choose your horizontal and get it right. So I'm going to switch gears here to start considering my profile. And sure, we'll pull this up. Now we'll pull this up. We'll add another curve here. Oh, I guess an IP to start. Now I'm starting to get to a point where my mass haul is looking reasonable. So we can see I'm close to balanced. Now I'm going to add in those vertical curves. So I'm assigning those with my K value. We'll go a little longer for this one. We'll go right down to the minimum So K12. And inevitably, this is, yeah, kind of, well, without optimizing, you never really know if you get it right. And you'll never get it as cheap of a solution as the optimizer. So we are going to try to get, we were balanced. I'm going to try and get my volumes to be a bit more reasonable. And we'll throw this in here as well. All right, so looking at my mass haul, I'm pretty close to balancing. Come down here, I am I'm moving way more dirt than Diego was. And like I said, it's iterative. We can keep chipping away at this. I could spend a long time on it. I'm never going to get as cheap of a solution as Diego. And yeah, to save boring everyone to pieces, I'm going to call that there. Now we can throw in a pipe, just as Diego did. Yeah, and it's kind of all the same from there on out. The big difference just being how we move, how we select that alignment. We can make our documentation the same way Diego did, export it for use for construction staking, but we still have our alignment. And then just if we want to do a cost comparison, I'll quickly just click recost here. And there I'm at 229.49. So that's my somewhat longer workflow for choosing our alignment location by hand.
Awesome. Thanks, Matt. Hopefully you enjoyed our little battle between our webinar hosts. So just to recap the results, if you weren't paying super close attention, I attempted to add these really quickly to my PowerPoint as we went, but Diego designed an alignment using the optimization tools with roughly half of the earthwork materials. So around 6,000 cubic meters of cut and fill. Similarly, with cost, he's a little bit less than half of Matt's cost. So Matt designed, with just over 13,600 cubes of material for cut, similar for fill, and a cost of about 229,000. In terms of the actual alignments, the visuals, again, attempted to cut these very quickly from their presentations as they did it, reasonably similar in terms of the actual alignment location. But all those little adjustments that are being done mathematically really do add up. Anyways, Diego, your optimism for winning, definitely warranted. So before we wrap up, I just wanted to highlight a little bit of a disclaimer. So obviously, optimization tools are an amazingly efficient element to add to your tool belt. But as an engineer, they by no means replace the impact that you have on your design. So after sort of a preliminary design phase where you leverage, say, optimization tools in order to help you determine where you should put your road, then going out and asking the question of why shouldn't I put my road here, we certainly encourage folks to be able to manually edit their designs in order to make sure you're meeting all your engineering needs. There's a lot of elements that obviously a computer and some really fancy math cannot account for. So as you go past preliminary design, we certainly encourage you leverage a combination of both. Optimization is just another tool in the hand of the engineer who wields it. So with that, I just wanted to thank everyone again for coming to today's webinar. Please be sure to go up to softtrue.com/webinars, check out our upcoming calendar. We'd love to see you at another webinar again soon. Thanks, everybody. Bye.